So we're back looking at our valve power amplifier build here, and we saw the sort of construction in a previous video. So this time we're gonna start to power this thing up slowly. We'll power it up stage by stage, make sure everything's as it should be, and then we'll see what the performance is like. So I think the next step here is we'll turn it over, put it in the cradle, and start working through, and then see how that journey goes. Here's our setup for beginning to turn this amp on then, just beginning to bring it to life. And we've got our onboard power supplies that we're quite happy to use for our heaters and also for the bias supply to the two main power valves. So that's all okay. But for the main high voltage rail, you know, we're not just gonna power that up and hope for the best. We've got a separate transformer here that we're going to bring up using the variac, so we can bring up that 400 plus volt rail slowly, and we'll just watch what goes on and make sure there's no funny business there that we need to be concerned about. So once we're kind of happy with the basic levels there, we've got an audio signal coming in here via our step attenuator, so we can kind of control the input level, and we'll look at the waveforms on the scope. And I guess we'll be monitoring some various voltages as we go along. So this is just a wider picture. We'll zoom in now and look at some of the details as we start to power this up. Right, so looking a bit closer now, and this unit's powered up now. So we've got our heater and we've got our bias supply. So if we just check on the input to our power valves, we can see that I've got minus 57 volts, and same on the other side. So that's our bias, and that's set to the minimum voltage or maximum negative voltage to give us the least amount of bias. So when we actually bring up our power rail, we're not going to be driving the thing hard. And at this stage I've actually got the power valves disconnected. You know, there's no high voltage supply in that. We're going to concentrate on turning this first stage on. So we just quickly check our heaters, kind of know they're going to be good, but there we are. They are just bang on our 6.3 volts as we've seen before, given the sort of fine resolution trimming we've got on our slow start circuit here. So that's all good. So we're quite happy then that these basic bias supplies are okay. The next thing we'll do now is start to wind up our variac and start to see our 170 and 400 volts on this input board, and then we can think about putting some audio in that, and we'll look at the various points, make sure we're seeing the waveforms we expect. Let's just monitor the 170 volt rail then here, and we'll start to turn up our variac. And of course there's going to be a time lag given the capacitors in our high voltage supply here, but we'll just wind this up slowly and look and listen for anything untoward. So we're reaching the 170 there, and we should be about 400 on this other supply here. 397. Let's tweak that up to the 400. So these are fine. Check again. Should be just over. Yeah, there we go. So these supplies are fine, and so these valves should be quite happy at this point. And we'll stick some signal in now and look at the various points on the scope. We'll just check we've got gain, we'll check we've got the 180 degree phase shift in our phase splitter here, and after that we'll begin to we'll attach our high voltage rail to the output valves and bring these in line. I'll let this stabilise for a while with these voltages as they were, just to make sure nothing happened over a bit of time, but we seem good so far. And so I've now got the scope connected to the output of the first valve, so we should be expecting some gain at this point. And so let's just turn up there. I've got 1 volt per division on my scope here, and turning up the input there, I'm just over 4 volts on the peak, and I can even go to 10 volts there, 5 volts a division, so I've got about 20 volts on the peak there. So that's looking really good, plenty signal coming out of that first valve there. So the next thing we'll do here then is we'll check the levels on the output of the second valve. So we should be expecting more gain, and 2 signals 180 degrees out of phase. So we'll need another channel on our scope, and we'll just check these levels. Right, connected to the inputs of the power valves now then. Still no power applied to the power valves, but we just want to check the output of our phase splitter, make sure our levels are stretching as far as we like and that we're 180 degrees out of phase. And if I turn up my input level here, I'm on 10 volts a division here, so 40 volts is the peak of the screen, and we're exceeding 40 volts there. And we can see we're 180 degrees out of phase as well, so we're quite happy that stuff's working. And you know, I'm going kind of flat top in there, up about near 60 volts on the peak. So that's fine, quite happy with that. And so I think the next thing now, we need to start applying some power to these output valves, and again we'll just bring things up slowly and see how things behave there. Right, so our output valves are now connected up, and the unit's powered up. I've went through this sort of slow turn on of this off camera, just because of the nature of this thing and the high voltages. I was just wanting to focus on what I was doing as opposed to filming it. But we're up and running here, and so these resistors here, these are our cathode resistors for the power valves, and we're looking at the voltage across them on this DMM here, and these are 10 ohm resistors. So the 400 millivolts then is 40 milliamps of bias in each of these valves. That's obviously quite low. You know, we're setting it low at this stage. We'll tweak that up in a second or two. But that's all running fine. We're quite stable there. And the other thing I've got here is my speaker outputs. This is from the output transformer. I've got the feedback connected, so I've figured out which orientation to put that in, and that's all working fine. So what we'll do is we'll just tweak the bias up a little bit, and then we'll see what happens when we put a signal through this thing. So let's just adjust this bias up a bit. We'll maybe just go up to about 50 milliamps at this stage, and you can see I'm able to get my hand through the front of this jig here and adjust that. So if we tweak up to sort of half a volt there, that's going to be 50 milliamps of bias. So we can tweak that up okay there. Overshoot a bit there. That'll do us there. That's near enough half a volt. Good enough then. And as I mentioned, we've got a scope connected to the output here. So let's see what happens when we turn the signal up. And there we go. So I've got 5 volts of division there, so I'm in excess of 20 volts on the screen there, and really my input level is checking out there before we're clipping, so that's pretty good. Obviously I don't have a load connected here, so that's going to affect things somewhat, but obviously we're amplifying, we're doing some good stuff here, so that's encouraging. And so what we'll do now is we'll kind of tidy up some of the loudspeaker wiring. We'll get that connected to the output ports. There's a few resistor values I'll maybe change to kind of tweak some of the intermediate voltages. So we'll do that, and then we'll come back and do some more detailed measurements. Alright, so I changed a few resistor values inside there just to set the operating point at some of the intermediate stages just exactly where I wanted them to be. So that's all good. And I've got the unit turned the right way around now. I'm still using my cradle so I can get some test leads and the like inside, but at least we're the right way up for a while. And given the valves are into the open air now, they're the right way up, I'm happier to turn my bias up to somewhere near where we might be operating. So we're up about 70 milliamps there. The reading's bobbing around a little bit, which is normal, but I think we'll need to add some filtering to that for the sort of complete solution. But good for now, it's bobbing around kind of where we want to be, so that's fine. So I think the next thing, we want to then connect the audio analyzer, and we'll start to look at some more of the detailed measurements for this thing and see how it behaves. Alright, so we've this is with the amplifier terminated. We've got a termination on the input, and then the output's connected to a load, and we're looking at the audio analyzer. And I've drawn this black line here that this is typically where the noise floor might be for some of the transistor amps that we've looked at, and this is for a comparable measurement. This is like for like, and we can see that we've got a much quieter noise floor in this amp here. And even if I put some averaging on, it's nice and quiet there all the way up the spectrum. And so the only thing we can really see here is a little bit of 50 Hertz there coming through, about minus 95. So that's about 20 microvolts we're seeing there. Very, very quiet indeed. We're never going to hear this, and this noise floor is exceptionally good. So super happy with that. Let's go and look at the wider spectrum then. We'll see, just make sure there's nothing untoward at the higher frequencies. Here we are looking at the wider spectrum then. We've gone all the way to a megahertz here, and our quiet noise floor goes all the way up here. Got a bit of spurious beyond 100k, but it's at levels that are just super low, and we're not really too worried about that. Suspect this is actually more pickup from our transformer. Our transformer's acting like an antenna at these kind of frequencies. So that's all quite good. So I think the next thing we need to maybe think about looking at distortion and setting our AC balance for that. So let's go and look at that measurement. Alright, so we're happy enough with our noise floors there then, so the next job is to put some signal through this amp and look at its performance there. So let's just turn on, and I'm asking just for just over a watt on the output there, so we can see that, and got a nice clean spectrum there, and second harmonic there is 70 plus dB down, so pretty good. And obviously we've still got our AC balance to adjust, and that should bring harmonic level down a bit again. So let's just flip to measure and distortion. We'll look at that AC balance adjustment and just try and tweak that in. So here we are looking at the distortion, and let's just go in here and we'll tweak our AC balance, and we should be able to dial that number in a bit. So that looks like that's going in the opposite direction. Let's just turn back. I can see the second harmonic drop in there just as I'm tweaking that adjustment. Let's see how far we can get this thing down. It's pretty good, below the 80 there. And we're starting to come back up. So I think just under 80 is about optimum. There we go, that's pretty good there. Right, so we'll leave it at that, 0.005%, that's pretty impressive. I'm very happy with that. Let's look at that in real money. So minus 87 dB on the distortion level there. Very, very good, very happy with that. Of course that's only 1 watt. As we increase our power, things are going to get a little bit worse as expected. Here we are up about 10 watts now, and obviously a much richer harmonic spectrum there, but still very good. Worst case we're down there sort of 75 on the third harmonic. Let's look at the distortion level that we get with that. So if we just go to distortion, and I'll move my graph a little bit, 0.024, so still very, very good. And if we look at that, so about 72, 73 dB. And so let's just go up to nearer our full power now, about the 30 watts, and we'll see what the numbers look like there. Here we are near 30 watts in the output then, and still looking good. Obviously again a much richer spectrum, but that's to be expected as we increase our output power. So let's just take a look at the distortion numbers on this. and we're still less than, well, about the 0.1%, which is pretty good. And let's just see if we've got any further tweaking on our distortion. Oh, there we go. So I can pull that second harmonic down just with my AC balance adjustment there. So that's impressive. I'm way below the 0.1% now. Can't really argue with that. That's probably optimum there. So at 0.07%, 30 watts output. Yeah, couldn't be happier with that. That's really good. Let's just go back and check our power level again. Yep, pretty much the same. So that's quite happy. Our distortion numbers are where we want to be, and so we'll go and look at just look at the bandwidth of the amp, make sure we're flat in terms of frequency response and things like that. Here we are looking at our gain and our frequency response, and we can see that we've got a nice flat response here with about 29.5 dB of gain. Let's zoom in. We can zoom in and we'll look at the measurement relative to 1K. Here's our response relative to 1K then, and very flat as we saw before, and we're maybe just like 1/10 of a dB lift down at the 20 Hz there, and up at 80K we're down sort of 2 3/4 dB, and for our 20K we're maybe what 0.25 down maybe. So very flat. Very happy with that, and this is a kind of statement for the transformer we're using here, for the output transformer here, performing very well. So I think we made a good choice there. So that's probably enough measurements on the audio analyzer here. I've done a lot more than I'm showing here. This is just the basics, and let's now we'll go back to looking on a scope, and we'll maybe put a square wave into the amp, and we'll just check everything's stable. There's no funny business going on when we put in some fast edges. Right, back looking at the scope here, and we're connected up, and these scopes are pretty useful because we've got a built-in function generator here. It's not a sort of super fidelity source, but when you're just looking for wave shapes and the like, it's just fine. So there we are, our sine wave out, and got just over a volt, and so that's good. And if we can change our wave shape, so let's then go down and look at a square wave. So we're looking very nice there. You can see our rising edge. There's no ringing, there's no funny business going on there. It's all very stable, and so we're quite happy with that. And of course that's a fairly low level. So let's say we'll change our scale there, and let's just change our amplitude of that square wave. And if we increase such that we've got an RMS voltage down here of about 15 volts, that's equivalent to 30 watts. And so we can see I'm rising this voltage here, and everything's fine. We're still the squareness isn't changing. Everything's all very stable. There's no kind of oscillations or pops or bangs or anything like that. So that again is a good sign that we've got things in a good place here. So I think the next thing we need to do, we've done a whole bunch of measurements here now, so we probably want to think about having a listen to this amplifier and just see how it sounds. So we're set up now. I've got loudspeakers connected, and got an input here via my step attenuator as usual. And the first thing, with no signal in this thing, there's just absolutely nothing coming from the loudspeaker. Zero hum, zero hiss, even with your ear right up against the loudspeaker. So that's really what we've been after, and what we're expecting given the noise floor plots we saw from this thing. So I have been playing some music, and it sounds very nice. We can turn it up here. So that's working just fine there. The problem is, of course, we've only got one of these, and we need a pair for our stereo. So that's the next thing now. I need to go away and spend a bunch more time. Got our boards here for the second unit, and we'll come back when that's done and have a proper listen. So here we are, a good while later, and I've got the second unit built. Made a few tweaks along the way, but both units are up and running now, and they sounding very nice. So let's have a listen here.